Pluto was supposed to be dead, frozen, silent, a forgotten rock at the edge of our solar system with nothing left to say. But when James Webb turned its golden eye toward this tiny world, something happened that made scientists stop, stare at their screens, and question everything they thought they knew. What Webb saw shouldn't exist out there, not on a world this cold, this far from the sun, this supposedly lifeless. Stay with me, because by the end of this video, you'll understand why Pluto just became the most mysterious object in our entire solar system again. Welcome back to Universe Proof, the channel where we chase down the strangest, most mind-bending discoveries happening in space right now. If you love stories that make you question what we thought we already knew about our own cosmic backyard, you are exactly where you need to be today. For decades, Pluto was treated like a punchline. Demoted from planet to dwarf planet in 2006, it became the butt of countless jokes, a symbol of scientific downgrade. But here's the thing nobody expected. The more we study Pluto, the more it refuses to stay boring. And James Webb just added a chapter to its story that nobody saw coming. Let's rewind for a second. In 2015, NASA's New Horizons spacecraft did something incredible. After a 9-year journey across billions of miles, it flew past Pluto and sent back the first ever close-up images of this distant world. What those images revealed shocked everyone. Instead of a dead, cratered ball of ice, Pluto had mountains made of water ice, a heart-shaped glacier the size of Texas, and even hints of possible ongoing geological activity. That heart-shaped region is called Sputnik Planitia, and it's unlike anything else we've seen on a small, icy world. It's smooth, almost crater-free, which tells scientists it's geologically young. Something is resurfacing it. Something is happening beneath that frozen crust. And that mystery has haunted researchers for nearly a decade. Now fast forward to today. James Webb Space Telescope, humanity's most powerful eye on the universe, has been quietly studying Pluto using a completely different method than New Horizons ever could. Instead of flying past and taking photos, Webb uses infrared spectroscopy, essentially reading the chemical fingerprint of light bouncing off Pluto's surface and atmosphere. And that's where things get strange. Webb detected unexpected patterns in Pluto's thin atmosphere, patterns involving hydrocarbons and haze layers that behave in ways scientists did not predict. Pluto's atmosphere is incredibly delicate, made mostly of nitrogen with traces of methane and carbon monoxide, and it actually freezes and falls to the surface as Pluto moves farther from the Sun in its 248-year orbit. But Webb's data showed haze layers extending and interacting with sunlight in a manner that some researchers describe as chemically active, almost as if Pluto's atmosphere is behaving more like a living, breathing system than the frozen afterthought we assumed it was. For a world sitting nearly 3.7 billion miles from the Sun, that kind of atmospheric complexity is genuinely startling. Here's why this matters so much. Pluto receives about 1,000 times less sunlight than Earth does. At that distance, most scientists expected chemistry to basically shut down, locked in place by extreme cold, reaching almost negative 400 degrees Fahrenheit. Yet Webb's observations suggest photochemical reactions are still happening in that thin atmosphere, breaking apart and rebuilding molecules in a slow-motion dance that shouldn't be nearly this active, given how little energy Pluto receives. Scientists studying the data have pointed to something called haze layer banding, distinct layers of atmospheric haze that shift and change with the seasons. On Earth, we're used to weather changing overnight. On Pluto, a single season lasts decades. So catching real atmospheric change happening on human timescales within the years Webb has been observing is exactly the kind of thing that makes researchers sit up straight in their chairs. Then there's the surface itself. Webb's infrared instruments picked up variations in ice composition across different regions of Pluto that hint at more complex geology than previously mapped. Certain areas show stronger signatures of exotic ices, methane ice mixed with nitrogen ice in patterns that suggest ongoing exchange between the surface and the atmosphere, almost like Pluto is slowly breathing across its own frozen skin. This ties back into one of the biggest lingering questions about Pluto, whether it might harbor a subsurface ocean beneath that icy crust. New Horizons already found evidence suggesting Sputnik Planitia might sit above a liquid water ocean, kept from freezing solid by heat from radioactive decay deep in Pluto's rocky core, insulated by a layer of gas hydrates acting like a blanket. If Webb's new atmospheric data is connected to activity driven by that hidden ocean, even indirectly, it would mean Pluto is not the dead, static world we imagined. It would mean there's an internal engine still quietly running beneath the ice, influencing the atmosphere and surface in ways scientists are only beginning to piece together. Let's talk about why this discovery genuinely stunned the scientific community. Pluto orbits within the Kuiper Belt, a vast ring of icy bodies beyond Neptune. Most objects out there are considered geologically inactive, frozen relics from the early solar system that haven't changed much in billions of years. Pluto breaking that pattern suggests our entire model of what small, distant worlds are capable of might need a serious rewrite. Think about what this means for the search for life and habitability across the solar system. If a small dwarf planet at the outer edge of our system can maintain internal heat, atmospheric chemistry, and possibly a liquid ocean, then similar conditions could exist on countless other Kuiper Belt objects we've barely studied. Suddenly, the outer solar system doesn't look so dead after all. Researchers involved in analyzing Webb's Pluto data have been careful, as good scientists always are, to avoid jumping to wild conclusions. Nobody is saying there's life on Pluto. But what they are saying is that the atmospheric behavior detected doesn't fit cleanly into existing models, and that alone is enough to reopen serious scientific investigation into how active this little world truly is. One of the most fascinating angles here involves Pluto's largest moon, Charon. Webb has also been observing Charon alongside Pluto, and the data shows fascinating differences between the two bodies, despite orbiting so closely together. Charon appears more geologically frozen in time, while Pluto continues to show these strange dynamic atmospheric signatures, deepening the mystery of why two neighboring worlds evolved so differently. Some scientists suspect Pluto's slightly larger size and stronger gravitational retention of its thin atmosphere might explain part of the difference, allowing chemical processes to continue that simply can't happen on airless Charon. Others believe internal heat sources between the two bodies may differ significantly, another thread in this unfolding cosmic mystery that Webb is helping us pull apart. What makes James Webb so uniquely suited for this kind of discovery is its incredible sensitivity to infrared light, wavelengths largely invisible to previous telescopes like Hubble. Pluto is so cold and so faint that studying its chemistry in detail was nearly impossible before Webb came online. Now, for the first time, we're getting a genuine chemical readout of what's happening in real time on this distant, icy world. It's worth pausing here to appreciate just how difficult this observation actually was. Pluto is roughly more 100 miles across, smaller than the United States, and sits so far away that sunlight takes over 5 hours to reach it. Capturing detailed atmospheric spectra from that distance, using a telescope stationed 1 million miles from Earth, is an almost unbelievable technical achievement. Scientists are now planning follow-up observations to track how these atmospheric patterns change as Pluto continues its slow journey away from the Sun, a journey that won't bring it back to this current position for over 2 centuries. Every new data point Webb collects becomes an incredibly rare and valuable piece of a puzzle that literally cannot be rebuilt on any human timescale we're used to. There's also growing interest in whether this discovery could reshape future mission planning. Some researchers are already floating the idea of a dedicated Pluto orbiter, a spacecraft that wouldn't just fly by like New Horizons did, but would stay in orbit for years, studying these atmospheric and geological changes continuously. If Webb's findings hold up, the scientific case for returning to Pluto just got dramatically stronger. Here on Universe Proof, we've covered a lot of strange discoveries across our solar system, but there's something uniquely humbling about this one. Pluto isn't a planet anymore by official classification, and it's easy to assume that means it's less important, less interesting, less worthy of our attention. This discovery is a powerful reminder that size and status mean nothing when it comes to the secrets a world might be hiding. It also says something bigger about how we understand the universe as a whole. We build models based on limited data, and those models feel solid right up until new instruments like James Webb reveal how much we still don't know. Pluto has done this to us before, and now it's doing it again, forcing scientists back to the drawing board on what counts as a truly dead world versus one that's simply been sleeping quietly, waiting for us to look closer. If you really think about it, this is what makes space exploration so endlessly exciting. Every time we think we've mapped out the rules, the universe hands us an exception. A tiny, frozen, distant world that shouldn't have any business surprising us keeps doing exactly that, decade after decade, telescope after telescope. Scientists are continuing to analyze the full dataset Webb collected, cross-referencing it with New Horizons imagery and running new atmospheric models to try to explain exactly what's driving these unexpected chemical signatures. Peer-reviewed papers are expected to follow as the research community works through the implications, and you can bet Universe Proof will be here to break it down the moment more details emerge. For now, what we know is this. Pluto's atmosphere is behaving in ways that don't match old assumptions. Its surface chemistry shows signs of ongoing change, and underneath that icy shell, there may be far more activity than anyone predicted for a world this small, this cold, and this far from home. James Webb didn't just take a picture. It uncovered a mystery that could reshape how we view the outer solar system for years to come. Before you go, I want to ask you something. If Pluto, a demoted dwarf planet billions of miles away, can still surprise the entire scientific community like this, what other secrets do you think are hiding in the dark corners of our solar system that we simply haven't looked closely enough at yet? Drop your thoughts down in the comments. I genuinely want to hear your theories. If this video blew your mind even a little bit, do me a favor and share it with someone who still thinks Pluto is boring, because clearly it never was. And if you're new here, hit subscribe and turn on notifications, because Universe Proof brings you stories like this one every single week, straight from the edge of what we actually understand about the cosmos. Thank you for spending this time with me today exploring one of the strangest discoveries to come out of the outer solar system in years. Pluto is watching quietly, patiently from billions of miles away, and it seems like it still has plenty left to teach us. Until next time, keep looking up, and I'll see you in the next Universe Proof video.